محل او شيء احمد والله هنا الغرض يعني بيشرب ميه ولا بيشرب مويه لا احتاج لانه اكل واجد فلازم اشرب الكثير واجد اكل.
Okay. Yesterday we went through the procedure. Yesterday we went through the procedure for calculating the level of service for merge or diverge segments. Okay. So the procedure follows. You should know the free flow speed. You have to convert the flow rates. Then you find out the flow rate in the first two lanes. You perform the check for the flow rate. You perform the check for capacity. Then you can calculate density, speed, and level of service and other things. Okay. This was an example which we are looking at, and I told you have to find out what the flow rates, right? The flow rates for the freeway and the ramp. Okay. So you have to find out the FHV factor, and then you divide the volume which is given with the FHV and peak hour factor. Same thing for both of them. What is the flow rate on the freeway? Does anybody have it? No. Okay. No problem. Moving on. We have a 6-lane freeway with an off ramp. Okay. Ideal geometry, meaning no correction factors required, no adjustment factors required. Okay. It has a level terrain, 70 miles per hour free flow speed. The free flow speed of the ramp is 35 miles per hour, and it has a deceleration lane of 950 feet. Okay. The freeway has a flow of 4850, and the off ramp volume is 800. Okay. There is an upstream on ramp. Upstream means what? Before. And on ramp means? Huh? No, very good. Huh? Merge. Okay. Centering. So that ramp, the before ramp, has 900 vehicles per hour volume. All traffic streams have 9% trucks and peak hour factor 0.93. Okay. Now the first step is we should know the free flow speeds. The free flow speeds are given. Okay. So I'll move on to the next step. If it is not given, I can calculate them. Okay. The next step is to calculate the flow rates. Okay. VF meaning the flow rate for the freeway. Okay. So volume given 4850. Okay. To convert it to flow rate, and flow rate should be in passenger cars per hour. The flow rate should be in passenger cars per hour. This is in vehicles per hour. Okay. So which factor do I need to convert vehicles to passenger cars? Heavy vehicle factor. Okay. So I need FHV. FHV is 1 divided by 1 plus PT ET minus 1. Okay. Percentage of traffic in all cases 9%. Okay. For ET we have the level terrain. Okay. For level terrain ET is 2. There is a table which is given earlier. Welcome. Okay, for ET we have a table according to terrain, but we have already seen that table number of times earlier and the traffic course. The factor is 1, but there's a table for ET. Okay, how much is FHV? 0.9, exact. Okay. 91? 92? Make up your mind. Okay, so FHV, because all of it is level terrain and all of them have 9% trucks. All meaning freeway and the ramp, both. Okay, so this factor will not change. If percentage of trucks change or the terrain change, then this factor will also change. This is what was happening in this example. We could have done it, okay, but we didn't do it. My fault, obviously. Okay, moving on. So now to convert the volume to flow rate, we are doing it for the freeway volume 4850, given peak hour factor, given 0.93, and this one 0.92. How much is that? 5, 6? Okay. Then for the ramp, we'll do the same thing, we'll just take the volume of the ramp, which is 800. Hmm? 935? Okay. The next thing is how much volume of the freeway will be in the first 2 lanes. How much volume of the freeway will be in the first 2 lanes? For we need the proportion. Okay, we need the proportion. So this is which section? Merge or diverge? Merge? Why merge? Why diverge? Off ramp. But there's an on ramp as well, right? Why? How do we know it's for the off ramp, not for the on ramp?
We have the deceleration lane.
Yeah, the length of the deceleration lane is given. Deceleration is for off. Okay, and the on ramp is upstream, so it's not in my segment. It is upstream. Okay, so we are doing it for the off ramp. It's a diverge segment. Okay, it's a 6-lane freeway. So one of these 3. Okay, my ramp is off. Okay, do I have any ramp downstream?
No.
No. Okay, so none. This one, this one, this one. 3 possibilities. Okay, upstream on. So only this one. Okay, they are saying it depends upon the value of LEQ. Which equation should I use? You have to find out the value of LEQ. Okay, but they are also saying check for this thing as well. What is this? Flow in the upstream ramp, distance to the upstream ramp. Okay, if this ratio is less than or equal to 0.2, then we don't need these 2. We will always use what? 5.35. Okay, so first of all, I'll check for this ratio. Now for the upstream ramp, there is the volume.
Occupy 668.
Okay, and it's half a mile. Okay, the first thing we need to do is, you see, everything is in what units? All volumes are in what units? Passenger car. So this one should also be converted to passenger car. This is the first thing we should do. Okay, so VU and passenger cars, the same factors. How much? 1052. Okay. In the equations, all lengths are in feet. In those equations, all lengths are in feet. So distance must be in feet. Half a mile equals to how many feet?
Two thousand 2,600 watt.
Sir, how much to convert from
600 to 500.
2643.
Convert from my
Point 39. The factor.
So VU upon LU, right? VU upon LU, right? 0.39. Okay. So we are not here. Equation, this condition is out. To check the other two conditions, I must know LEQ. How much is LEQ? One of these. Okay. We have upstream on ramp or downstream off ramp. Which one do we have?
Upstream.
Upstream on ramp. Okay. So LEQ is the first one. We know everything, right? Okay. So how much is LEQ? VU upstream one. How much? Let me write these values. How much is VU?
1052.
1052. VF 5. How much?
5660.
And we are
935.
you are 935.
Yeah.
And only 10-12 people.
8073.
What is this? LEQ. Okay. And how much is my distance to this ramp? The it was how much? The 26540, right? LEQ is 807. Okay. So distance is less and LEQ is more. Okay. Distance is less, LEQ is more. Okay. Okay, so we have got this condition, right? We have this condition. So I will use equation 5.36. This one. Okay, so how much is PFD now? Okay, I want to calculate V12. For V12, the equation is this one. Where is it? It's a diverge segment, we'll use it now. Okay. So how much is V12? Okay, after that we have a number of checks. Okay, two of them are for the outer lane volume. Okay, first of all, do we have outer lanes or not? In this case, do we have outer lanes?
Yes.
How many?
One.
One. Okay, so what is the volume in the outer lane? VO, okay. How much is it? So, this is in the inner lane. This is in the first two lanes, and whatever you have is in the outer lane. Remaining is in the outer lane. Remaining is how much?
1,900.
You subtracted from what?
VF from V1.
VF? VF only? You will need it in this. I can give you something else to eat. Yes. Yeah.
From V1.
V12? From VF, sorry. VF? How did we calculate V12?
Yes, the ramp also we have to.
The ramp was included, right? The ramp was included. Okay, so you have to include the ramp as well. Because people are going where? To the ramp, right? Okay, so there, whoever wants to go on the ramp, he's where? On the freeway. Okay, so that's why these two. So your total is, because ramp volume is already on the freeway. Right now it's on the freeway. It will go out from the ramp later when it reaches the ramp. But right now it is on the freeway. Okay, so when you are calculating volume for the outer, you will do it from the total. Okay, the total is both.
Diverge.
Diverge. The merge is easy because the ramp will come after. Ramp volume will come after. So there is no problem for the merge. Okay. So from the total, you will calculate V outer from the total. You have to add both of them and then subtract, because this is what they did when you are calculating V12 as well, right? So what was the total? Total should be from here, right? From the flow rate. It was 5668 plus 935 minus 3680. So how much is that? 2923. Okay, now we said we have one outer lane, right? We have one outer lane. Okay, there are two checks. The first check says that per lane outer volume. So only one lane. So this is per lane. Okay, should not be more than 2700. It should not be more than 2700. Okay, is it or not? It is. Okay, if it is, then V12 will change. Okay, V12 will be BF. Okay, so 5668 minus. But is it one lane or both lanes? Okay. Yeah. Sorry. Okay. So now V12 becomes what? Okay. This is my new V12 according to the first check. Okay. The second check was per lane outer should be less than or greater than? Father? Less than.
Or equal.
Okay. So this V12, so first of all we have to convert it to per lane. So 2968 in 2 lanes. So how much in 1 lane? How much in 1 lane?
1484.
Okay. So we are saying the per lane outer should be less than or equal to 1.5 times this value. Okay. So per lane outer is now how much? The new V12 changes, the V outer will also change, right? Okay. So how much is that? So again we'll do the same thing. Okay. But instead of using 3680, we will use 2968. Huh? Okay. And 1.5 times of 1484 is how much?
1226.
Huh?
Trouble
2226 is what?
222.
No, no, which one? Which value is this?
1.5 times their name.
Per lane. Okay. So this is now more. Okay. Okay. So we did not. Yes, any problem?
No, no, okay.
353.
Sorry? The outer was what? How come this is you made a mistake here. It should be from total, right? This should be from total. We're doing total, right? So how much is that?
Because the F also included VR, right?
Yeah, yeah.
3903. 3903.
Okay. Then per lane is how much?
1.5.
Okay, and 1.5 times of this value? Uh-huh. 2928. Okay, so we are still. No, our volume is how much now? It's 2700, right? Our volume is 2700. This one is 2700. This was V outer, right? Okay, so now this one is 3903. This value is 3903. So V outer will be 2700. You can put it. It will be 2700, right? Right or not? Why did we do this? Why did we do this? Why did we change the V12? Because the outer lane was
More
than. So we set it on 2700. This is how we satisfy the check, right? Otherwise you will keep on doing this. This check is still not satisfied. Okay. So from the total, okay. So now we have new V12. From the total, subtract the new V12. Okay. And you should be getting 2700. Okay. I know you don't trust me. Do it. Huh?
So
From the total, we subtract the new value. How much did you get? The total, subtract the new value. And we are getting how much?
Sure. You are right, sir.
Huh?
My calculator answer.
Hey, what are you doing since 5 minutes?
Correct.
Correct, right? Okay. So keep in mind, I'm correct. Okay? Alright. Till I give you the final grade. Okay? Till I give you a final grade. So trust me. You trust me now, trust me then as well. Huh? Okay. Not other loans. Okay. So 1.5 times of this is how much? 29 something, right?
Yes.
Okay. So now we are less. Okay. 1.5 times this value is more than 2,700. Still less. People do it. Okay. Clear? Something says that you are there for sleeping. Don't do this. Come here. Now you confessed. Come here. Come.
سنتي أعزم عليك يا حمود. لا نزاد مو خاطر اليوم صدق.
إذا بندخل بعد الصوت
زين ضايع كان. يدل عنا ما يقدر يبني. عليكم السلام.
See how nice. These are nice people. Okay, this check satisfied. Now we move on to the capacity check. If capacity check is not satisfied, the level of service is? The level of service is what? If capacity check doesn't satisfy, the level of service is? F. Okay. What are the capacity checks? The capacity checks are first of all, the flow rate on the ramp. Okay. Flow rate on our ramp is 935. 935. Okay. It should be less than its capacity. Okay. What is the free flow speed on the ramp? What is the free flow speed on the ramp?
7.
No. On the ramp. 35. 35 is here. Okay. So the capacity is 1900. No problem. Okay. The flow is less. This is more. Okay. Then the capacity of the freeway. What is the free flow speed of the freeway? 70. The capacity is 2400. But this is per lane. Okay. What are the flow values I have per lane? How much? Per lane. What is the flow in the outer lane? What is the flow in the outer lane? This is capacity of freeway segment. Huh?
The slides.
Back.
1952. Okay, the capacity there is 2400. No problem there. But where's the problem? For the outer lane. Okay, for the outer lane it is 2700. Okay, which is more than the capacity. Okay, so the segment will have level of service F. Okay, you cannot have one lane having F and the other lane has something else. Okay, the segment one lane has F, obviously people will go where? To other lanes. Okay, so they will disturb everybody. Okay, clear? And this, so we can stop here. We can say, okay, this segment has level of service F because of the volume in the outer lane. Clear? Okay. Now we had two examples. I'm very sorry I couldn't do the first one for you guys. Okay. Now, just for the sake of practice, okay, so this is, we are doing diverge area, right? Diverge area. What is our total volume V12, total, the new one? 39 something, right? 39 something, okay. My capacity for the diverged influence area is 4,400. So there is no problem. Here there is no problem. Okay, clear? Okay. But we have level of service F. No problem with that. We know that. Okay. But for the sake of practice, okay, we will calculate the remaining things. Just calculate them. Level of service we know. Okay. We can calculate, for example, the density. Okay. The density needs V12 and the deceleration rate, the length of the deceleration rate. Okay, V12 is 3903, right? And deceleration lane in the question? 950? Okay, how much density? Okay. Clear? Any problem till now? Now you may see that the density is less than is somewhere here. Okay, but it was expected because see first. It is, where was F? In the outer lane. Okay. There, yes. Are you using anything from the outer lane here? No. Okay, so that's fine. Okay. If you do some sort of combined calculation, you may see F there as well. Okay. Then again, we can calculate the speeds as well. This is the speed of the influence area. This is the speed of the outer lanes. Okay. So we need VR here. We calculated the speed of the ramp, which is 35. Free flow speed of the ramp, 35. This we don't need. So we'll calculate ds first. Okay, and then you can calculate the speed for the ramp influence area. How much is that? So this one we are not using. We are using this one. What else do we need? SFR means free flow speed of the ramp, which is 35 miles per hour given. VR, you already know. And what else? Per lane volume for the outer lane is, 2,700. You know that. How much is DS? How much? 0.5. Sorry, DS. 0.5. Then SR is how much? We don't need anything new, right? FFS for the freeway, 70. What density? Not density. DS. This value you calculate. 56 miles per hour. Okay. For the outer lanes, you can have this condition or this condition. Depends upon V of the outer lane. Okay. So V of the outer lane in our case is 2,700, right? 2,700. So we are here. We'll use this equation. You already know everything. BOA is 2,700. Huh? 70.16.
Yes.
We are using 70 here.
70.
Okay, minus. So how did it go up because of this? This entire thing into 1,700, right? 2,700 minus 1,000, right?
Yeah.
So 1,700. It goes more than that? Huh? It shows that these equations are not for level of service F. Okay, they are not giving accurate answers. That's why they give us a check that you should stop there. Okay, because if you continue, the equations will give you some answers, right? They will give you density, they will give you speed, but they are not supposed to work after level of service F. So that's why they gave us the check that when you don't perform the check, don't satisfy the check, you stop there. Level of service is there. Don't go there. Okay, they know that the equations are not good.
Expired.
Hmm?
Expired.
No. They said it only works before level of service F. Okay, so that's why. You stop. Okay, clear. Okay, we are just doing this for the sake of practice. Okay, in the exam or any other practical example, you say level of service F proved by the capacity check, you stop there. That's it. Okay, clear. Any questions? Okay. Up till now we have seen merge segments and diverge segments. Okay, merge means you are going in, diverge means you are going out. Okay, if these segments are very close to each other, if merging and diverging is happening very close to each other, and on ramp and off ramp, they are very close to each other, then that becomes a weaving segment. Okay, that becomes a weaving segment. Weaving is, weave the clothes, you tie the threads and so on. The thing which the tailors do, that is weaving. What? Yeah.
حتى الدقات لازم تركز هي عشان تفهمهم، لما تركز ما تفهم.
What? Yeah, he's my translator. Yes. Okay. So, an on ramp followed by an off ramp, and one more condition, that they are connected by an auxiliary lane. So these two ramps are connected with a common lane. Auxiliary means it's a common lane. It's a common extra lane which is going from the on ramp to the off ramp. Okay, so you come on the freeway from this lane. Okay, if you continue, it will take you to the off ramp. Okay, this is how we do the U-turns on some of the highways, right? With the bridge and so on. Okay, so two main things for the weaving segments: on and off ramps are close to each other, so they are affecting, and there is an auxiliary lane which is connecting them. Okay, clear? What are the important things on the weaving segment in terms of traffic flow? Number of lane changes. How many lane changes are required by the people who want to go from one direction to the other? Okay, and how many lane changes people are forced to make because of your lanes? Okay, so number of lane changes required because people want to go from the freeway to the ramp or ramp to the freeway. This is required, right? Required by them. And how many lane changes you are forcing, that you have to make this one, okay, because of the design. So this will affect the traffic flow. Obviously, when people change lanes, it affects the traffic flow, right? They are crossing each other. That's why we call it weaving. Okay, number of lanes available from which the lane changes will happen. Okay, and the length of the auxiliary lane. So how much distance is available between the two ramps, basically. The auxiliary lane is the distance between the two ramps. Okay, so how many lanes you are providing, how many lane changes are required and forced, and how much is the distance between the two ramps, which means the length of the extra lane, the auxiliary lane. These three things are the main unique factors for the weaving. Obviously we have speed, density, flow, gradient, all these things affect traffic flow. We know that. Okay, we saw them in basic freeway, we saw them in merge segment, diverge segment. We have looked at all these things. But these three are more important for the weaving segments. These three parameters are more important for the weaving segments. The other parameters are there, but these are three extra. Okay, so what's the problem on the weaving segment? We discussed it for the merge and diverge as well. People have to go in to the freeway and go out, and both these things should happen at what speed? High speed. Okay, so it's something like this. It doesn't work. Very good. It will work in this slideshow, but anyways. Some of the examples. Okay, this is the bridge which is near the Ansar Gallery. Okay, so there actually there are more than two. There's two, one on ramp, and then there are an off ramp. Then you go forward, then there's another off ramp, and so on and so forth. Okay, so there are 2-3 ramps in the same interchange. In this same portion, you will see 2-3 ramps. Okay, on each side. If you are here, you have two options. You can go in from here, you can go in from the other side. If you go forward, then people are coming from here, and you go more forward, then again there is an off ramp again. Okay, so this becomes a weaving segment. They are very close, like few meters. Okay, from here to here, maybe it's total 500 meters, and you have 3-4 ramps here. Okay, this one is near the Isa Town campus. Okay, if you are coming from the driving school, and you take the left turn towards the campus, okay, or towards Sheikh Salman Highway, Salmawar. Okay, so there is a ramp which is coming in from the Indian school, and then you can take the exit for the towards the campus. Okay, so this is happening very short distance. Obviously, I did not take the distance, but it's very close. So this is like a weaving segment. Okay. Yes.
The right turn and the signal.
Signal is not included here. No signal is included. There is no signal here because we have what? Merge, diverge, weaving. All of them are on which highway? Freeways. Freeways don't have signals. Okay. What methodology we are going to perform? We have to collect input data. The most important item, obviously, we have seen it earlier, is the volume. You have to find out the weave configuration. Weave configuration means the lanes. Configuration of the lanes. Total number of lanes, number of auxiliary lanes, number of lanes for the freeway only. You have to find out these things. They are called as weave configurations. So weave configuration is basically the number of lanes. Okay, and different types of lanes. Then find out maximum weaving length. Okay, I told you if the two ramps are close to each other, then it becomes weaving. The on ramp is here and the off ramp is after 10 kilometers. Even if you give a common lane, nothing will happen. Okay, nothing. If you have ramps like this, you come from the ramp and you continue in your lane for 3-4 kilometers, you will not see another off ramp. So this is not weaving. Okay, although there is an extra lane on which you came on from the ramp. Okay, but this is not weaving. Okay, so before you start doing your analysis, you must check, do I have a weaving segment or not? Okay, so we have a maximum weaving length, we calculate it, and we compare it with the actual distance between the two ramps. If the actual distance is less than this, we have weaving. If it is more than this, then we have what? In out is what? In and out. What is that? Merge. Okay. Then you will treat it as two separate segments. The on ramp becomes merge segment. The off ramp becomes diverge segment. Okay. So you will treat it as two separate segments. If the actual distance is less, then the whole on-off becomes one segment. That is weaving. Okay. Again, checking the capacity. Okay. More than capacity F, not, then we will continue. Find out the rate of lane changes. This is the lane changes per mile. Total lane changes, you will calculate it and you will divide by the length of the segment. Okay, then find out the speed, density, and level of service, the same things which we have done earlier as well. Okay, what is the input data you need? You should know how many lanes you have, how many freeway lanes you have, and how many auxiliary lanes you have. Okay, the extra lanes between the two ramps. It can be one, it can be more than one as well. Okay, so one is not fixed. Short length of the weaving segment. So the distance between the two ramps. The distance between the two ramps, and this distance is measured from this point to this point. Okay, the connection between the ramp and the freeway. Okay, so you will not measure this distance from here to here. You will measure it from the connection point. Okay, the ramp is connected with the freeway at this point, right? Okay, so from the connection point to the connection point. Okay, we call it what? We call it the gore point. Okay, so all distances related to the ramps are measured from the gore point. If you have to measure a distance to upstream ramp, downstream ramp, all the distances we mentioned, deceleration length, acceleration length, all of them are from the gore point. Okay, okay, and what is the gore point? The connection between the ramp and the freeway, the connection point. Okay. Yeah, so short length of weaving means the distance from gore point to gore point for the on to the off ramp. Where are the ramps? On the left hand side of the road or the right hand side of the road? You should know that. How many lane changes are required? Lane changes can be of three types. Required lane changes are of three types. People going from ramp to freeway, so they come from the on ramp, go for the freeway. Then freeway to ramp, they are already on the freeway, going out, exit. Then ramp to ramp, like a U-turn. Okay, so these are the required lane changes. All the lane changes required by these people. Number of weaving lanes. Okay, what are number of weaving lanes? Weaving lane is that lane from which you can do freeway to ramp or ramp to freeway with maximum one change. A weaving lane is that lane from which you can go freeway to ramp or ramp to freeway with only one change. If I'm on this lane, can I go to the freeway with one change?
Yes.
We are still sleeping here as well. Huh? Artist. I had the artist with the eyes open. This one moves as well. One change. See, you are on the ramp, you go to the freeway. Okay? One change, right? One lane change. So, this is a weaving lane. This is a weaving lane. Okay? So I'm on the freeway. Can I go to the ramp with one change? So this is the weaving lane. This one and this one. How many?
Two.
Two. Okay? Two. If I'm in this lane, can I go? So I'm on the freeway, right?
Yeah.
Can I go to the ramp with one change? No.
No.
So this is not. This is not a weaving lane. Obviously from here you cannot do it. Okay? So put yourself in any one of the lanes and see, can I go to the other side? Other side meaning if you are on the ramp, can you go to the freeway with one change? Okay? Or can you go to the ramp with one change if you are on the freeway? Okay, the other side. Freeway to ramp, ramp to freeway. If you can do it with one change, that's a weaving lane. So you count how many lanes, from how many lanes I can do this. Okay? Number of weaving lanes.
So it's always two.
Those two, yeah.
Always true. Most of the time. They will show some other examples as well. Interchange density, number of interchanges per mile. Okay, interchanges is the connection between the two roads which are at different levels. Okay, so how many interchanges you have per mile? Terrain type, we know, gradient, level, rolling, blah blah. Okay, capacity of the basic segment, basic freeway capacity. Basic freeway capacity for which we have used the equation earlier. Okay, so basic freeway, the capacity of a basic freeway segment without ramps. Okay, so we have an equation for that. We basically need the free flow speed. If you have the free flow speed, you can calculate the capacity. We have equations. Okay, demand volumes and the parameters of the volume for the freeway and both ramps, on ramp, off ramp. Last question. What do we mean by parameter of the demand? Which parameter? Tell me. There are two things which are related to demand. So we have demand volume, right? Demand volume, this much volume. Which other parameters you would ask me? We have used it. No, no. How do we calculate the flow rate? Yes. Yes. Peak hour what? We already have that. Peak hour factor. To convert to flow rate, we need peak hour factor, right? And one more thing. The percentage of heavy peak. To convert to passenger cars. Okay, so these mean the percentage of heavy peakers and the peak hour factor. Okay, clear?